Hello friends and welcome again. And I have updated this sheet with a few more features. I have updated all this this whole tab EW columns for defining end wall columns, that is first end wall and last end wall, then fascia, roof monitor, bracings, and purlins and guts. And further, I am going to add canopy. So after adding this last feature, all the this sheet will be ready for PEB buildings. I think 95% of the cases can be covered by this sheet alone. Right now, bracing is partially working. Maybe in couple of days it will be working with full effect. Uh, Still, the work is going on. So I'll quickly show you all these features. Uh, Root cases, these are all the same as it were earlier. And in design, I have put one tab whether we need to design the purlin instead or no. We'll just put it no forwards. Now let's take a example. Length of the building is 120, width is 95, and we have taken 3D frames. Multi-span 4. One thing more, this bracings and purlins and guts will only work for 3D frames, not for 2D frames. But obvious, it cannot be uh, modeled for 2D frames. So 3D frames. Now multi-span 4, and we have added this all uh, spans. Now directly we will go to the sheet. Here we have shown that for each span and span width is given. So we have to input the column position from the zero location. So here for this span from zero location, first interior column at first end wall will be at 7, then second is at 14. So after 14 we cannot like put it 21 because at 21 we have already have it one column. So if we put in number more than 21, it will show not okay. So remove this. Same for this second span. The width is 20. So from the first it will be 20, 7 and 14. Then for the third span, I have kept at 6.5. 22nd is the fourth span is 22 meters. Then it will be 7 and 14. I have just put like this. Now, if you want fascia, you can consider yes. Now, fascia height, let us consider 5 meters. Uh, let us change the heights. Like if for the left wall, I want for 3 meters, and for the right wall I want for 5 meters, and then I also want some width, that is for the gutters, and for first end wall and last end wall it must be at the ridge location or something about the ridge. So the width is 95 meters and the building is 1 jump 10. So the 9 point, there will be a rise in height of 9.5 meters approx. So let us consider 10 meters, 9.7 meters on first and last end wall. There is an option to give the width also. We can give the width also. But since this is an end wall, I am not keeping the width. Now for the roof monitor, we can click yes if you want it. Then we can give the grid line number. So the last grid line is 18. Sorry, the frame. Total grid lines are 17. If you say base spacing, so number of bays are 17. So total number of frames will be 18. So I have considered second to 17th frame. You can consider any. Then its height and width. Now for the purlins and girds, I have considered two options for purlins. That there will be only purlins that will be connecting end wall columns. So this annual columns throughout that will be connecting. Then there is a second option. If we say this no, then there will be a second option that we can give a Perlin spacing of fixed 1.5 meters. So first of all, I will consider only annual columns, and always we can give different LVOLs. The program will automatically connect the Perlins. Let us see. Let us take in this example. Let for span 4, we will take 6, 12, and 18. And for here span 4 is 7 and 14. So the annual columns are not equal on both the sides. Okay, so this is the option whether we want to give the my or mz release for the police. I'm just clicking it no right now, so that the stat file will be generated will be without the release. We can click yes for release. And here also I have given one option whether the annual columns must be released at the end location. So you can click yes or no. Let us say click yes, so that annual columns will be released on the top. Now here I have clicked released as a no. So purlins and guts won't be released for my and mz for the this consideration. Now for the bracings, I'll take it in next example. So this changes I have done. Load cases I won't change anything. Wind loads, then anything I won't change, and directly we'll click the stat file to generate, and we have to give the location to save. Now it is saved. Now before opening that file, I'll quickly take second example. Let us take multi-cable 2. So multi-cable 2 width is 95. So 32, 31, 32. That is okay. Now in annual columns, we have to change for this 2. Let us say 8, 16, 24, then 8, 16, 24, 8, 16, 24. You can always delete this unwanted numbers, or you can keep it. The program won't take it. So I have given the span. Now in this, we will generate purlins with fixed spacing of 1.5 meters. So 1.5 meters. Let us see release. I'll give in this example release option also. Okay. And now for this example, since it is a multi-gable building, and the ridge of all the gables will not be more than this, like let us say, see it is 32 meters maximum. So it will be like divided by 2, that is 16. So 1.6 meter above this. So for the previous example also I have taken this 9.7 is very much, because the total width 95 divided by 2. So I think 4.5 meter only I did to give, but okay, I have given is 9.7. That is okay. Now for this gable, we will just select 4 meters and 4 meters, and let us see we can give some width 0.2, 0.5. And now for this, I'll also show this bracing. It is not fully functional. Only a middle portion will be showing the bracings. So okay. Now, whenever we are generating these GURDs, there will be some node overlaps, but you can always remove this overlap nodes from the stat tool of generate duplicate to remove the duplicate nodes. So there is no problem in that. Now we will generate this. After generating the stat file, always check for overlapping members, uh, then duplicate nodes, overlapping collinear members, 2 3 checks, so that we will be certain that our model is okay. Now we will see both the models. Now first the first model, it was a multi-span 4 building. Okay, it is generated. So you can see these are the all fascias which we have given 9.4 meters. This is our roof monitor, and this end walls they have been given released at the top. All these end walls, and you can see that from the roof, if you see that since here I had given two purlins, two end wall columns, it has taken two purlins, and here I had taken three end wall columns, so it has generated three purlins at the central location. Okay, so fascia is there, and roof monitor is there, and all the girts and purlins are modeled. And you can always select if you don't want purlins or girts, you can click no. If you only want purlins, you can click only purlins. Anything is possible. I will also show you that in design, automatically takes only those elements which you want to design. So if you had clicked the design of purlins and girts, it would have taken the design of purlins and girts also. Now this LZ can be for all the end walls also. You will get the LZ, and for all the this fascia, you will get the KZ value as 2 as per our polar provisions. If you zoom it here, you will see that on the left hand side we had given some spacing 300 mm spacing. So the program has generated 300 mm spacing, and in the front fascia we have the program has taken the front fascia as in the line with the cladding. Now if we had generated both this in the line with the cladding, then one of these two would have been there in the program. The program will automatically take only one if we are generating all the four sides as straight. See, if you want to check the height, this side we had given 5 meters, and this side suppose 3 meters, 3 meters. This side I think from eve we have given 9.7 meters. So it will gradually reduce at the center. So it will always keep this line straight. If you want to see like this is always straight. So 9.7 meter is from the eve. Okay. Also roof monitor is added, and all its relevant wind loads, dead loads, everything is added. If you see in the wind load, I'll quickly show. Remove this. And wind load is also added, and this is the load on fascia. Wind load on fascia. So for every case, it has been loaded. And this is the wind load for roof monitor, and this is for the frame. All the similar frames will show the wind loads similar, and all the different frames will show the different. So all load cases, all the cranes, crane combinations, everything is a design. Also, we'll see this next test file. That was multi-cable 2. Since we have added bracings, it is showing two errors. Still, it is in development mode, but these are all very small errors. It will be released in the. It will be removed from the next version. So I quickly select no. Now, if you see, all the purlins and girths are given released. M, MX and MZ, MY, MZ. And if you want to see the frames, all the frames, with fascia, with roof monitor at every center, and in this case we have taken both sides as both side fascia with small bracket. So both side fascia with small brackets, and purlin will be is given at 1500. Let us see. So I have removed the releases, and as I told you that this is just under the release, so the bracings are yet to be. So if you see the bracings, I had given in second, then 7, 12, and 16. Uh, so second, 12, 7, 12, and 16. It has taken the bracings. Still some development is there that to connect it with the columns and then to the walls. So that will be developed, and one more feature will be added. Last feature, that is canopy. After that, the program will be fully completed. So you can generate any kind of building, any kind of accessories with this program. And for high bay or mezzanine or something, it can be, this model can be edited to suit as per as actual plan or something. But approximately 90 to 95 percentage of the PEBs is all are covered in this Excel sheet. 95% of the building will be covered in this. Exceptionals for high bays, mezzanines, or something else, or different shape that can be modeled. Thank you.